Right, problems 4 and 5 from outcome 4. I'm going to do sort of two problems at once here just because they are so short. Just put them in one video here. So for this problem, what it's asking you to do is to be able to look at an original function and then some transformation, something's been done to that first original equation or original function, and your job is to figure out what effect would the changes to the rule or to that function have on the graph of the function. Okay, so we're going to look at the first function, f of x equals x squared, and they've applied this new rule, right, or new transformation to this original function. So they're taking the original function, multiplying it by -4, and then adding 3. Okay. So anytime you see something being done like this to the original rule, it really does not matter what the original function is in this case, okay? Whether it's a linear function or quadratic, things like that. All we're looking at is these two numbers right here and thinking about what that's going to do to the graph. Now, anytime you add a number outside of the parentheses, okay, I want to specify that because if you look in question 5, they're adding inside and something different will happen there. You may remember this already, and I'll give you a second to think about it. What effect does adding a number outside the parentheses have on the graph? If you remember correctly, that is going to shift our graph up. So this +3 is going to shift the graph up 3 units. Okay, shifting the graph up 3 units. So that takes care of what the +3 does. Now the -4. The symbol, the negative symbol, is going to change the direction of this function. So this is a quadratic. X squared is the most basic, y equals x squared, or f of x equals x squared, the most basic quadratic. Okay, it comes down, turns, and goes back up. Right. So it's opening up, but now that we're multiplying it by a negative, the graph is going to now open down, which means it is flipped across the x-axis. And our function has also increased its output values because we're taking every original output and multiplying it by 4, which is going to make it 4 times larger, if that makes sense. So for instance, if we previously had a y value of 1 when we plugged in a number, now that value is going to be up at 4. Okay? Except it is going to be a little bit different because we are multiplying it by -4, so it's coming down here actually. So this was previously 1, 1. Now that point is at 1, -4. And then we shifted up 3 units. 1, 2, 3. So it would end up at 1, -1. Okay? But the -4, all that is doing is stretching our graph vertically. Okay? It is going to look 4 times as long as the original graph did. Now, I mentioned the shift up 3 at the beginning just because that's the most obvious one, but normally if you were actually trying to figure out the y values, you would figure out the actual input or actual output value from the original function, multiply that answer by -4, and then add 3 just because of the order of operations. Multiplication comes before addition. Okay, so these are the things that's happening to that graph. Stretching vertically 4 times as tall, opening down, so it's basically flipped over now, and then it's shifting the graph up 3 units. From there. Okay, second function. I would suggest maybe pausing the video right here and seeing if you could answer this one on your own, but I'm going to go ahead and talk through this one. So it says 1/2 g of x plus 3, where originally g of x was just x squared. So x plus 3, the +3 this time is inside the parentheses. So see if you can remember, what does adding inside the parentheses do to our function? Hopefully you remember. That is what is going to shift our graph either left or right. Adding or subtracting inside moves it left or right. Adding or subtracting outside moves it up or down. Now, if you remember correctly, adding inside, it's actually sort of opposite of the way we originally would think about this. We originally would think adding, oh, you're going farther this way to the right, because going farther to the right means you're actually increasing your number when you look at the x-axis. However, adding actually will shift the graph left 3 units. It shifts in the opposite direction, shifted left by 3 units. And then the 1/2, if multiplying it by a number bigger than 1, such as 4, stretched it vertically, made it 4 times as tall,
this is going to make our graph look like it shrinks our graph vertically. So in other words, if we originally had a graph that looked like this, all right, crossing y equals x squared, now this new graph is going to be shifted left 3 units. So instead of touching down at 0, it's going to touch at -3. It's going to come up. But then I'm going to take that and I'm going to stretch that out vertically. Every point is going to be half as tall. Okay, so let me make that a little bit better. So it's going to look half as tall when you take a better look at your graph. Right, so it's shrinking. Every y value is half as tall, and it's been moved left 3 places. So hopefully this clarifies some of the just adjustments that can be made to rules by multiplying by constant terms, by positive or negative values, and then either adding or subtracting outside or inside your function rules parentheses. Okay. So try these out, make sure you understand them, and go ahead to the next problems.